So now we're going to talk about midpoint. So this is going to be this is going to be a tiny bit different from your between. Whenever we did the segment addition postulate, okay, this is where I had you guys highlighting the word between, because you're going to have to look for between and midpoint. So the first one we'll talk about is what a midpoint is. The midpoint of a segment, okay, it's going to be the point that divides the segment into two congruent segments. So we'll go ahead and draw what we have over here. M is the midpoint of segment AB. So we want to draw segment AB. Remember, we don't have arrowheads because it stops. Segment AB. M is the midpoint. So what that means here, so segment AM will be congruent to segment MB. Remember, we talked about segments are congruent. The length, the number value of AM will be equal to the number value of MB. So we can go here and we can put these little congruent marks showing that they are congruent. Put that in a different color too. So we have congruent markings. That is what your midpoint does. That's the difference between segment addition with between and midpoint. Your segment bisector. Your segment bisector can be a point, a ray, a line, or even a plane. A lot of times we see it as a line or a ray, but it's going to intersect the segment at its midpoint. Okay? So the midpoint or a segment bisector bisects the segment, hence why it's segment bisector. Whatever it is going to bisect the segment. So here we have line CD is a segment bisector of segment AB. So let's draw segment AB again. Here's segment AB. And we're going to have line CD. So here's a line with our arrowheads on it. So here's C and here's D. It is going to bisect right here. Okay, we'll call it M for midpoint. And it's going to create those two congruent segments just like before. Okay, but this time instead of just a point, midpoint, we have a line going through it. And remember, when a line and a segment intersect, they also intersect at one point. So that point of intersection, because it is a bisector, segment bisector, that point of intersection is going to be your midpoint. Now, your midpoint on a number line is simply just taking your two coordinates, adding them together, and dividing by 2. That's it. Okay? So we find the coordinates, the midpoint of FG. So what we can do here is you're going to be introduced to what they call midpoint. That is your abbreviation for midpoint. Your midpoint, okay, of segment FG is going to be equal to, well, we need to figure out our coordinates. Well, F is at -3, so we have up here x1, okay, and here's your x2. We have -3 plus x2 plus your +3 over here, all divided by 2, as it says right here. So we go through and we find, well, -3 plus 3, they cancel out and make a 0. So we have 0 divided by 2. 0 divided by anything is simply 0. I just put the line through it so you know it's not an O. So there's our midpoint. And if you take a look, if you start moving, you go 1 this way, 1 this way, taking 2, 2, 3, 3. Oh, they meet right here. So between point F and our midpoint is 3 jumps. Between G and our midpoint is also 3 jumps. And we find ourselves right here at your midpoint. Your midpoint. Okay? Now, in the next example, we don't have the line, so we're going to use, we're just going to use our numbers here. So here we have, we've got AB. This one's going to change a little bit also because we're going to have to work backwards. Okay? The coordinates of the midpoint, so we're looking at the midpoint on AB is 3. So this is going to be M for our midpoint. And our formula up here, M, midpoint. So we will have a number to fill in there. A is at -2. We want to find B. So we write down our formula. Midpoint is going to be your two coordinates A plus B divided by 2. So let's take a look at what happens here. Let's substitute in. We have our midpoint was 3. That is equal to A, negative 2, plus B, which we could put in as X, our variable, right? Or we could just put in for B. We'll just leave it as B. All divided by 2. So the first thing we need to do here is we need to get rid of the 2 in the denominator. And as we looked at when solving for our variables, if you have that 2 in the denominator, all you need to do to both sides is multiply by that 2 so that they cancel. What you do to one side, you must do to the other. So then we wind up with 2 times 3 is going to give us 6 equals. We have nothing over here on the bottom anymore. All we have is negative 2 plus B. So we take our next step. We need to get our constant to the other side. We're going to add 2 to each side. These cancel. And we're left with, making sure it's still on screen, B on this side. And 6 plus 2 is going to give us 8. So that's you're working backwards with that formula. All right? Let's take a look at the next page. We are looking at M is the midpoint. So that's what you want to highlight, midpoint, so you know which formula to use, of segment VW. We want to find VW. So we need to find the whole thing here. We're not using a part plus part equals whole this time around. Okay? We are going to be we're just going to, because these two things are congruent, right here we can write in, said segment VM is congruent to segment MW. We can conclude that the length of VM is equal to the length of MW. So all we have to do is set those two together. We don't need a whole. This is not a part plus part equals whole. These two are exactly the same. So let's take VM. What was VM? VM was right here, Z plus 2. So I'm going to take Z, and I'd put that line there so you don't think it's a 2, because my Z's and 2's look a lot alike. So you can see. We're going to set that equal to the length of MW. This is that midpoint. We set them equal to each other. So we have 2Z minus 6. We go through our process of solving for X. Okay? Move my variables to one side, so I'm going to subtract this Z from both sides. I'm left with 2 equals, well, I have 2 Z's, I take 1 away, I only have 1 Z left. Bring down that minus 6. We add that 6 to both sides, so these cancel out. Z is going to equal 8. Now that's not what they wanted. They wanted the length of the entire thing. Well, one way you can look at this, guys, is you don't need to do Z plus 2 plus 2Z minus 6 and substitute in for both. Because these are congruent, okay, because of the midpoint, you can say that the length of VW is equal to 2 times whichever one you want, because they're both exactly the same. Well, Z plus 2 looks easier to substitute in for me, so we can do 2 times VM. Okay? So when we go through, we do our substitution here, we're going to have VW is equal to 2 times Z plus 2. I'm going to write in my algebraic expression here. So now I'm going to go through, I'm going to substitute in. 2 times, well, over here I found out that Z was 8, so I'm going to substitute in for 8 plus that 2. We'll bring that down step by step. This is going to end up being 10. So we have 2 times 10, making the length of VW total of 20. And if you want to go substitute in for both, well, 8 plus 2 gives you 10. 2 times 8, 16, minus 6 gives you 10. Then 10 plus 10 is going to give you that whole 20. Okay, this is the easiest way to do that, though. So we're going to take a look at example number 4. Skateboard, segment VW, right here, bisects segment XY. So segment XY is the one being bisected. So we're going to put those congruent marks immediately. Okay, and it's going to bisect right here at point T. XT, okay, from X to T is going to be 39.9 centimeters. We want to find XY, the whole thing. Well, what we know is that from X to T is equal to T to Y, all right? And if we add them both together, XT plus TY, we're going to get the whole length. So we do use a little bit of that segment addition. So we'll have the XY. But the difference between the segment addition and this midpoint, again, is that we know that both these parts that add to equal the whole, okay, again, this goes back to your part plus part equals whole, but both your parts right here are equal. They're exactly the same. So if XT is 39.9, so is TY. This is also 39.9 because this is your midpoint. It's in the direct middle. Okay? So all we do is we have 39.9 plus TY right here, another 39.9. We add those together, and we're going to end up with your XY. And your XY is going to equal, when we add these two together, you're going to get 79.8. And there's our answer. All right? The next problem, example 5, we're going to skip. Okay? We're just going to go ahead and skip that one. And we're going to take a look at midpoint on a coordinate grid. Originally, these notes had the coordinate grids. I don't know what happened to them, but we don't need them. We're going to practice using this right here, our formula. Okay? So I make sure that we're looking at this formula here for midpoint on a coordinate grid. Now, this is not the number line like we had over here. This is on a number line, one-dimensional. Now we're looking at two-dimensional. So we're going to need that X1 and Y1 again. So let's take a look at the first one. The endpoints of segment RS, or R at these coordinates and S at this. We want to find the coordinates of midpoint M. So using this formula, we're going to take M, our midpoint. We're going to go ahead and go up to R and S, and we're going to label X1, Y1, X2, Y2. Okay? So in our formula, we have X1, negative 11, plus X2, 8, all over 2. Now we're looking at two different coordinates. That's going to be our new X coordinate. Okay? Now we're going to find out what our new Y coordinate is going to be. Y1, 3, plus Y2, negative 7, all divided by 2. Look for those words, distance or midpoint, and figure out which formula you need to use. So step by step, we're going to go ahead and solve in the numerator. Negative 11 plus an 8. Okay, so negative 11 plus 8, we're going to have a negative 3 over 2. Okay. And then for our Y, we have 3 plus a negative 7. We're going to end up with a negative 4 over 2. Last step, go ahead and do our division. Negative 3 divided by 2 is going to give us a negative 1.5. Negative 4 divided by 2 is going to give you a negative 2. Okay? So this will be our answer for our coordinates. Now, the next problem that we're going to look at, we're going to have to work backwards. This one takes a couple different steps. We have the midpoint, M, is at 3, 5. So in our formula, your midpoint is at 3, 5. This will be equal to one of the endpoints A of AB is going to be at 0, 1. So here's your X1, Y1. We don't know our X2 and Y2 yet. So when we plug into our formula, okay, again, I'm going to write over here since it's at the top and off the screen, your midpoint is X1 plus X2 over 2, Y1 plus Y2 over 2. So over here we're going to have Well, we have our x1, 0, plus we don't know what our other x is. So we'll have our x2. We don't know what it is, all over 2. So then when we look at y, we've got y1, which is 1, plus we don't know what the other y is, all over 2. So you have to take these and you have to separate them, okay? First, we're going to take the x right here, and we're going to set that up as an equation. Separated. Your midpoint for x is 3. We're going to have this equal to, and we're just going to set this guy up, just our x coordinate. 0 plus x over 2. And we're going to go ahead and solve it just like we did with the number line on the first page. We're going to go ahead and multiply both sides by that 2 in the denominator so that these cancel. You're going to wind up with 6 equals 0 plus x. Whoa, we don't need that 0, right? E automatically goes away. So your x coordinate is going to be 6. Kind of easy on that one, right? Not too bad. If we take a look at, let's see what color I want to use. Our y, 5, we're going to set it up with this guy over here and do the same thing. So now we have, for our midpoint, 5 equals 1 plus y over 2. Cancel out your denominator first by multiplying both sides by 2. We're going to find out that we have 10 equals, this is gone, only a 1 plus y. And with our math, we know that we need to get this constant to the other side, so we're just going to subtract 1 from both sides. These cancel. We're going to find out that y is going to equal 9. So, in the long run, when we're finding that midpoint, our other endpoint b, b's coordinates are going to be at x, 6, 9 for the y. All right, and that is it. We are done with that and done with this unit's notes.